Okay, so start recording. This is the third recording that I'm making because we have some problems with the interface for PLC Ladder Simulator 2. So again, it's because yun nga, it's not very neat pagdating dun sa pagkaka-arrange nung output-input niya. Okay. So let's do a I/O manager first. Okay. So tatanggalin ko lang tong kaya ako inaakyat. Okay. Tinatanggal ko lang yung zoom na toolbar. Okay. Para makita ko yung ginagawa ko. Okay. So push button. Okay. Yung first na ano natin, we'll set it to start. Okay. Digital ano pa rin siya. Okay. Yung second one, we'll set it to stop. Ngayon yung stop, temporary lang siya. Okay. It's not a permanent item dun sa scheme of things. Okay. Balik ako. It should be a push button para pag pinarest mo, pag nirelease mo, tapos na yung emergency stop action mo. Okay. Next is our analog in. Okay. Maybe we can do away with an analog input kasi that is a potentiometer para lahat doon na lang sa loob. We'll see. Baka naman pwede mag-set ng variables na lang dun sa system. Okay. So let's rename the output. Yung first natin, we change to S1. Yung second natin, we change to S2. Okay, S1 again, dun sa previous video, is the forward action. S2 is the reverse. Kung pump siya, S1 would make the pump put in water dun sa endpoint niya. Okay, o yung termination point o exit point niya. Pag ni-reverse mo kasi yung pump, well, if it's not a Wellington vein na ginagamit, it's supposed to suck fluid from yung port out niya papunta na naman dun sa source previously. Okay, so ganun yung consideration natin for this one. We assume na it can do a reverse rotation. Kung fan yan, yung S1 nagpapasok ng hangin dun sa target area. Pag in-S2 mo, nag-extract naman siya ng hangin dun sa target area. Okay. So that's the most simple way to go about it. Okay. Yung out 3 naman, babaguhin natin para maging equivalent na siya sa A1. Okay. Again, this is an analog output. Let's set it to 0 to 10 para meron ng time variation. Okay. So we're done with the inputs. Let's go with the ladder editor. Okay. Oh, sorry. Pwede bang variable manager? And then we can add variables naman dun sa loob. Okay. Let's add some variables. Okay. Real variables na pwede natin i-call out mamaya. Okay. 50%. Okay. So, ang 50% for a 10-bit item natin, 50% 124 sa ano eh. 124, okay, that's 7. 255, that's 8. Okay. 512, that's 9. Okay. 1024. So the value of this one is 512, 50%. Okay. Tapos mag-add pa tayo ng iba pang real variables na iaano natin. 20%. Okay. 20%, 25% of so 1024 divided by 4. Okay. So you'll have 2, 3. So 100, sorry, 235. Okay, yung value niya. Okay. And yung final set ng real values natin that we want to introduce into the system is 75%. So, bakit ako naglalagay ng percent form? Okay. This is intended to be sequenced into the controller for specific conditions natin. Okay. Pag nag-change tayo ng values dun sa speed niya. Okay. So, we have 75.75, well, 235, 235, 235. So, we have 15, 5, tapos 10, 0. Okay. Tapos 2, 7, 700, yan, 705 yung value natin. And then finally, yung final value natin for the real, ano natin is 100%. Okay. And here, we place in 1024 dun sa value niya. Okay. So, start. Okay. Normally close contact. Okay. So, again, i-move ko lang tong nakakairitang bar ng Zoom. Okay. We'll use the stop function. Ayun na siya. Okay. So, start, stop. Ito yung consideration natin dun sa sa S1 natin. Okay. Let's add in a rung. S2 naman to. Okay. Okay, S2. Add. Okay. Tapos mag-add din tayo ulit ng normally open na start. Okay. And add a normally closed na stop. Tapos, let's add in another contact in direction lang para meron lang tayong direction control. So, this is a third input na wala dun sa original IOS na manipulate natin. Okay. So, let's set this one to I2. Okay. Mamaya babaguhin na lang natin yung pangalan para mag-correct siya doon sa ladder diagram. Normally closed. Okay. I2. Okay. So, this would suggest kapag na-press siya, the motor moves forward or air goes papunta doon sa target. Kapag hindi siya nakaset o naka-depress siya, okay, the air is being sucked out of the target area kasi S2 yung naka-open. It's moving in the counterclockwise direction. Okay. So next, I'll just fix the I2. Exit ko siya. I go to IO manager. Okay. And then let's revise the third one and make it into their O direction. Okay. So yan na siya. Okay. So next na problem natin. Let's go back to the editor. Okay. By the way, just to make sure, exit ko yung editor, i-save ko muna yung design. Okay. Just to make sure na kapag biglang nawalan ng kuryente, hindi mawawalan na yung itong value na to. Okay. So next. So let's go into edit the ladder diagram. Okay. Let's add in a value ng output natin. Okay. So the target value that we want to to look into is supposed to be our value para dun sa position natin ng rotation o yung bilis ng rotation natin. Okay. So let's do move operations kasi mag-move lang tayo ng data natin. Okay. The input digital boolean for this one, let's assign it as this 4. Okay. I3, I4, I5, I6 natin na values. Or maybe we can use a virtual trigger point na lang dun sa ano na yun kasi we can do a valid number of dispositions for it. Yung analog output na pupuntahan natin nung real value should be the second analog output A1. For this one, we can set it as a constant variable. Okay. Okay. Ayan. Dito ko na lang kukuhain ngayon yung 50%, 25%, etc. So let's start at 25%. Set ko na lang siya. Okay. So ayan yung ano natin. Okay. So just to explain kung anong tinetesting kong gawin dito, we'll add a new rung lang dun sa system. So the rung is supposed to be centered papunta dun sa V0 natin, which is the trigger point for the move command. Okay, ito siya. Okay. So, this trigger point, we can set it for the variables natin na nandun sa kabilang side. Okay. So, meaning to say, ito yung titingnan natin. I3 is open. Okay. I4 is closed. Okay. Tapos I5 is also closed. So, yun yung condition set natin. Kailangan ma-meet niya to para ma-trigger tong isang to. So, we can exit the location, save the design. Okay, I'm saving it on a different spot just in case magloko siya. Okay, VFD2. So, we can simulate the exercise. Okay, start. Tapos, meron tayong direction. So, S2 siya. Okay. Na-notice yun, 325. Lumabas yung value ng output natin. Okay. Pagka pinatay ko to, yun, nakikita niyo, ito na yung nagbumabalik siya sa, hindi siya nabalik sa 0. Okay. So, yun yung problem natin ngayon. There should be another line like this and another move command na naka-associate to bring it back to 0 kapag ganito yung states ng switches natin. Okay. So, stop natin siya. Okay. Okay. So, since we're using a unpaid edition, may nalabas na ganun. Okay. So, back to the ladder editor. Okay. We can add again another move command. Ito yung hindi ko magawa dun sa sa kabilang ladder simulator. Okay. Input, we'll set it at another one dun sa virtual inputs natin. Ang output natin is still the same. A1 pa rin yung tina-target natin. This time, okay, we'll get a variable, pero the variable is associated with one of the preset items. Again, medyo overkill yung ginagawa ko. Okay. Kasi nakaset na yung real values. Pero you can actually type it here as a constant. Okay. So, yan yung sa A1. Okay. Mag-a-add ulit tayo ng additional na move. Okay. or maybe it's better to place in a new rung para ito yung system na nag-govern para dito sa isang to. Okay? Para hindi tayo nalilito. 0, 1. Okay. Ayan na siya. So itong line na to, yung 6 na nagko-control ng triggering ng 5. Okay. So in this case, we can have the variable input 3 natin as normally closed. Okay. Tapos, the variable 4 natin as normally open. Tapos, the variable 5 natin is normally closed. Okay. Sorry. Open. Okay. So, yung fifth natin, naka-close siya. Okay. So, this is 50%. Okay. Yung 75% natin, okay, pwede natin siyang gawin ng, well, we need to add in another move na naman, move data. Okay. So, M2 na siya. Okay. Tapos, ang analog out natin is A1 pa rin. Okay. Tapos, the variable that we're using is the assigned 75% natin dun sa system. Okay, yun na siya. Add in a rung. Oh, sorry. Baka. Okay. Digital output coil. Okay. Yeah. Output coil normal. And then we'll go to M3. Yun yung trigger point nitong isa. Okay. We'll add in additional values dito to differentiate it from the others. Okay. Normally open 5. Okay. Tapos, normally close dapat siya dito sa isang side. So, 3 and 4. Okay, so yan na yung value for this one. That's 75% ng speed niya. And we need 2 more dun sa move operations natin para magawa natin siya. Okay. Again, M4. Okay. Analog. A1 yung 0 out natin. Okay. Variable. Okay. We set it here as 75, 100%. Okay. So, ayan yung 100% natin. Okay. We add a rung, M4 na rung. Okay. Ayan siya, M4. And then we add in a few more items. Okay. Just to make sure, again, save ko lang yung design. VFD2, save. Okay. Let's go back to editing. So in this case, this is 100%. Kailangan natin siyang i-differentiate dun sa iba. We can set it to a point na 2 of these are actually turned on. So, pwedeng yung 5 at saka yung 4 yung iaano natin, isi-set natin sa kanya. So, I4. I5. Okay. Tapos normally close yung I3. Yep. Okay. So, again, yung rung 10, nagko-control nung operations ng rung 9. Okay. Let's add in one more para do sa zero operation niya. In this case, again, sorry, M5 siya. Okay. Yung trigger point natin. Okay. Yung A1 na output ang tina-target niya. And the variable that we're including is 0. Okay. Tapos we need to add in one more rung dun sa ilalim. Okay. To sequence it to M5. Okay. Na okay. Maximize. Okay. Okay. So, for the love of me, I cannot see kung nasan yung isa. Bring that one there. How can I do a screen up dito sa ano na to? So yun yung problem. Maybe we can set to delete this one. Function lang. Ito, i-delete natin. Okay, para makita lang natin muna yung control line, tapos i-add na lang natin yung isa. Okay. So ito is normally closed yung I3, I4, and I5 natin. Nanin mo. Okay. I5. Okay. And then, at saka natin i-add, since hindi ko makita yung, yung move operation ng isa, ngayon ko siya i-add dun sa ilalim. So, nag-switch yung rung 11 at saka rung 12. Okay. So, again, the analog output A1 yung target. This is manipulated by M5. Tapos yung variable, constant natin is 0. So, yun na siya. So, exit ko yung editor. Again, for purposes of being safe, i-save natin yung program. Then, we start the operation. So, pagka pinares ko to, nag-reverse ng direction niya. Okay. Pagka pinares ko tong isa, okay, I get the value ng 25%. Pag pinares ko to, I'm getting a value of 512. Pag nilagay ko to, okay. Okay. So, nakita ko na kung anong problem ko. 512 is 10 daw, according to this one. Okay. So, yun yung limit nung issue. Okay. So, may add na naman siya. Okay. So, let's go to I/O Manager. Click then edit on this one. Yun, 8 bits lang kasi. Should be the 12 bits natin. Okay. So, X, play ulit natin. Yan. So, 25%. Okay. Half ng value, 50%. Okay. So this is A1 destination, which is 0 siya ngayon. Okay. M2 yung nakasulat dito. M3 yung ginamit ko. Okay. So, that's the incorrect one. Again, tayin lang natin na konti. So, let's do an edit. Function. Sorry. Na a function. Sa coil. So, the function niya. M3. Sorry. Okay. 3 kasi to eh. 1 tong isa. 4 tong isa. 5 tong isa. Okay. So, I'm guessing okay na yun. Save the design. Again, slot 3. Okay, play. Okay. So, 0, 25%. Okay. 50%. 75%. Okay. 100%. Okay. So, yun yung case dito sa ano natin. So, 100% based dun sa bit size natin. Maybe this one is what? Different. 125 lang to. 250 lang siya. Dapat 10 to. So, I'm guessing may mali na naman ako dun sa ano, sa I/O manager. Let's move this one to 11 bits. Let's see kung ano mangyayari. X play 5 volts. 10 bits lang pala dapat. Okay. Exit the editor. Wala na akong i-edit out dun sa ano. Yung I/O manager yung problem ko. So, 0. Yan. X. Okay. So, again, so pagka sinet ko siya, start. Okay. 25%, 50%, ano, 75%, and then 100% or 10 yung volts yung nalabas sa kanya. So, itong A1 ngayon yung analog signal mo to control the speed kung ganyan yung case. Okay. Now, for purposes lang of the stop function, kita niyo nawawala yung signal dun sa ano. So, that's basically stopping all the occurrences nung signal natin dun sa VFD to turn the motor. So, that's more than enough to do that. Okay. So, I guess yun na yung katapusan nung sa VFD and the PLC interface to a VFD. Now, ano lang yung maganda dito? If you have an AC motor that you don't want to tax, or merong cases na kailangan mo mabagal mag-spin yung motor, like nasa-sense mo yung outflow dun sa tangke ng tubig na mabagal siya magbawas, pero you want the motor to replenish the liquid na nandun sa loob, kung water yun or kung a chemical substance, pero hindi mo gusto na yung motor mag-spin at maximum speed, you can use a VFD para mamomodify mo yung speed niya appropriately. Instead of running it at 100% kagaya ngayon, okay, pwede mong iset siya ng, okay, ng 25% lang. Ngayon, kung malapit nang mapuno, you can send a signal which is basically null. Okay, wala na. Papatayin niya yung motor. Nakatigil lang siya. Once na nag-dip na yung level to a specific value, okay, pwede ka na mag-add in ng 25% para mabagal lang yung outflow. Kung continuous pa rin yung losses mo dun sa water, pwede mo increase to this one, 50%. Kung hindi pa rin makuha dun, okay, you can go to this one, which is 75%. Kung sobra na, yung pwede mo siyang iset dun sa kabila, which is the automation ng 100% natin. In this case, hindi siya umaabot ng 24. Pero if your PLC is a 24 volt PLC, it's more likely that its analog output can reach up to 24 dun sa system natin. Okay. So I guess that covers it. Medyo mahaba lang yung kasi I was still formulating kung paano siya gagawin dun sa mismong ladder diagram. Pero that finishes the recorded video for VFD setup using J1000 VFD and a PLC based on the PLC Ladder Simulator system na that is readily available on Android. Again, kaya ako pinili na ito yung gamitin kasi it's interfaceable to a Arduino Nano. So if you have home automation projects that you want to do, a cheaper alternative to buying a PLC is getting an Arduino Nano to do the job for you. Instead na bibili ka ng mahal na PLC for one specific purpose ng automation system lang. It's a lot more cheaper. Tapos pag nasira pa, cost like 200 pesos lang kada isa. So not much of a bother pagdating dun sa replacement cost mo. Okay. So I can probably end the video now. I'll see you all again in the next video.